Emeka right here. This is my last video on velocity time graph. You may watch my previous videos, my previous teachings on velocity time graph, and I guarantee you that when you do this, you'll be a master in what? In velocity time graph. And also endeavor to share my videos with your friends and subscribe to our YouTube channels. Now let's take a ride. A train starts from rest from a station and travels with uniform acceleration 0.5 meter per second square for 20 seconds. It travels with uniform velocity for another 30 seconds. The brakes are then applied so that a uniform retardation is obtained, and the train comes to rest in a further 10 seconds. Sketch the velocity time graph of this motion. Using your graph, calculate the total distance traveled by the train. Okay, now we are going to start by making a sketch of this graph, and it normally looks this way. This is the part of velocity, and this is the part of what? Of time, measured in seconds. Now, a train starting from rest means that we are going to take what? We are going to start our diagram from this point, because this is the rest region, starting from rest. Now, it starts from rest and travels with uniform acceleration of 0.5 meter per second square for 20 seconds. Now, this is a graph of a velocity time graph, and now acceleration has come into play. But this is a graph of velocity against time. It now means that we are going to convert our acceleration to what? To velocity. And what is the formula for doing that? That v, which is the final velocity, is given as what? As the initial velocity plus the multiplication between acceleration and what? And time. Now, starting from rest, whenever a body starts from rest, it means that the initial velocity is what? 0. So we are now going to be having that v is what? 0 plus acceleration, which is 0.5, multiplied by the time, which is what? Which is 20. And that will give us what? That will give us 10. So that means that we are going to have this. From the graph, we are going to have this. This is 10. And that happened what? That happened in 20 seconds. Now, it travels with uniform velocity for another 30 seconds. For a graph of uniform velocity, it looks this way. Just make a sketch like this. That is a graph of what? Uniform velocity for another 30 seconds. So for that 30 seconds now, coming to our time region, we normally add. So 30 plus 20 will give us what? That will give us 50. Now the brakes are then applied that a uniform retardation is obtained in a further 10 seconds. Uniform retardation obtained in a further 10 seconds. Now for uniform retardation, we just have this. In a further 10 seconds, for our time region, we add 10 plus 50 will give us what? That will give us 60. Now, the total distance traveled by this train obtained from the graph, what do? For distance in a velocity time graph, we consider what? The area under the graph. And by area under the graph, we solve for the area of the figure that we have. Now, this is a trapezium. That's a trapezium. Obtaining what? The total distance traveled by the train means that we're going to be solving for the area of the trapezium. And that distance x is given as, the distance s is given as half in brackets from this point to this point, which is same as from this point to this point. And we are going to subtract. 50 minus 20 will give us what? That will give us 30 plus from this point to this point, which is what? 60 multiplied by the height, which is from this point to this point, same as from this point to this point, same as from this point to this point, which is what? 10. So we now have this. Our distance now is equal to half in brackets. Addition of these two will give us what? Will give us 90, multiplied by what? By the height, which is 10. 2 into this will give us 1, into this will give us what? 45. 45 multiplied by 10 will give us what? 450 meters. This is the total distance traveled by the train. It's been nice having you all along, and I hope to meet you more and more. Thank you.